Good day, everyone. Let us try to solve this factorial problem from the United Kingdom. And this is the problem. Find the values of a, b, and c wherein any of them cannot be zero such that abc is equals to a factorial plus b factorial plus c factorial. Now, the problem is asking us to find a three-digit number so that the number itself is equals to the sum of the factorial of its digits. Now, since the number has three digits, we're going to look for numbers that have factorials that are equal to a three-digit number. Now, let's try to explore the factorials. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, and 7 factorial is 5040. Now, again, the number should only be a three-digit number. But 7 factorial is equals to 5040 that has four digits. But since we only need a three-digit number, we cannot include 7 factorial. Therefore, we are going to exclude it from the list. That means we cannot have 7 as a digit. So we're only left with 1 factorial up to 6 factorial. Now, let's try to have 6 factorial. Now, since 6 factorial has a 7 in its digit, we cannot use 6 factorial again because 7 has already been eliminated from the list. So we cannot use 6. Let's now have 1 factorial up to 5 factorial. Now, the highest possible sum, if we're going to use 5 factorial, is when we use the 3 5s. So, 5 factorial plus 5 factorial plus 5 factorial is 360. But if the 5 will be taken as the values of a, b, and c, then a, b, c as a number is 555, which is surely not equal to 360. Therefore, we cannot have all three digits that are 5. So let's try one of the digits to be 4. Now, 5 factorial plus 5 factorial plus 4 factorial is 264. And 264 is obviously not equal to 554, so we cannot use this. Now, let's try to have 5 factorial plus 5 factorial plus 3 factorial. If you're going to add all of them, that will not be equal to 553. So we cannot use this. Now, if we're going to use 552, that will be 5 factorial plus 5 factorial plus 2 factorial, which is again not equal to 552. So we cannot use 552 as well. Now, let's go to 4 factorial. The highest possible sum that we can get when we use 4 factorial is when we're going to use the 4 as the value of a, b, and c. So if we use 4 as the value of a, b, and c, then a factorial plus b factorial plus c factorial is equals to 4 factorial plus 4 factorial plus 4 factorial, and that gives us 72. And 72 again is already the highest value. But remember that ABC has to be 3 digits. Therefore, 72 is just too small. So we cannot use 72. That means we cannot use 4 factorials. That means 1 factorial should be at least 5. So let's use 4 factorial plus 4 factorial plus 5 factorial. Now, the 4 factorial plus 4 factorial plus 5 factorial is equals to 168. But 4 factorial plus 4 factorial plus 5 factorial, if we're going to use the 4, 4, and 5 as the 3 digits, that would be equal to 445. And certainly, that's not equal to 168, so we cannot use this. And so therefore, let's try to use another combination, which is 4 factorial plus 3 factorial plus 5 factorial. If you add these factorials, that will give you 158. But if we use 4, 3, and 5 as the digits of the number, then that becomes 435, which is again obvious that is not equal to 158. So we cannot use 4, 3, and 5. This time, let's try the combinations of 5 factorial plus 4 factorial plus 2 factorial. That gives us 168 as the sum. But 5 factorial, 4 factorial plus 2 factorial, if we take the digits as the number, then that is 542, which is not equal to the sum that is 168. So we cannot use 5, 4, and 2. Now, for the 5 factorial plus 4 factorial plus 1 factorial, the sum is 145. If we combine these numbers, if we form this into digits, this is 541, which at the first look at it is not equal to 145. But remember, addition is commutative, so if we rearrange the addends, we will still get the same sum. That means if we have 1 factorial plus 4 factorial plus 5 factorial, we will still get the same sum as 5 factorial plus 4 factorial plus 1 factorial, which is equals to 145. And then if we're going to rearrange the digits and try to form a new number out of the rearranged digits, you have 145, which is again equal to the sum that is also 145. And this is now the answer, and the problem is solved. So that's it for this video. Please don't forget to like and subscribe to our channel to be updated on more challenging algebra problems. Thank you so much. Enjoy learning.